Hi, my name is Mr. Nguyen's, and I'm a math and business teacher, not a computer science teacher. But today, we're going to learn how to code with a lesson from Canada Learns to Code. Have you ever received an email or phone call that sounds something like this? Do you think it sounds authentic? This email is an example of phishing. Phishing attacks are web pages designed to look identical to trusted websites on the internet. The goal of a phishing website is to have you enter your username and password so an individual can store them with evil-minded intent. Although phishing is common, there are other ways illegitimate organizations or individuals try to obtain your password. Take a look at these passwords. Can you rank them from most secure to least secure? We will now check out a website with some code that you can use to try and crack the passwords. This program uses brute force and dictionary attacks to guess your password. Were you surprised at all by those results? Why do you think some passwords were guessed quickly in mere seconds and others were never cracked? Brute force attack is when a computer tries random combinations of characters until it guesses the password. Now think about what you use a dictionary for. A dictionary attack is when a computer guesses commonly used phrases and words stringed together. The toughest example of a password had a combination of upper and lowercase letters, numbers, and special characters, so it was much tougher to crack. Alright, my name is Mr. Nguyen's, and I'm going to take you through a lesson about computer science that was made by Canada Learning Code. So start off with, what is a computer scientist anyways? Problem solvers that work on the software and hardware in almost everything that we use nowadays. But coding is only a small part of their job. Let's take a look at this lesson about why computer science matters.
So, what grade are you in?
Second.
10th grade?
First grade.
I was in 8th grade when I learned to program.
I got my first computer when I was in 6th grade.
What gets me excited is being able to fix people's problems.
You can express yourself, you can build things from an idea.
Computer science is the basis for a lot of the things that college students and professionals will do for the next 20 or 30 years.
I like programming because I like helping people.
I get the opportunity to build something that's going to make people's life easier.
I think it's the closest thing we have to a superpower.
Getting started is the most important part.
I'm a beginner myself, and I want you to learn with me.
So, as you can see, computer science is all around us. It's everywhere in almost everything that we do. So what is programming? If you learn to speak French, it's so that you can speak to other people who can speak French. Computer programming is just like that. It's learning a language to speak to computers. And just like any other language, it has its own syntax, its own grammar that you have to use in order for things to make sense. We're going to look at a computer language called Python, and it's pretty great. It's new to me. I'm not an expert or anything, but you know, it's free and it's open source, which means that anyone can contribute to it, anyone can add to it, and build upon it. It's used in all kinds of different industries and apps and programs. And so by learning this language, you should be able to talk to a lot of different kinds of computers and a lot of different kinds of softwares. It's the third most widely used programming language in the world, and we can actually use a source, REPL.IT, that will allow us to play around and start using Python as a language along with other languages. But we'll start with Python by using this website here. So if you start by typing repl.it into your browser, and we will create a login. We'll have to sign up the very first time using your student email. So if you click on the Google You can actually sign in using your student email address. When you're signing up, you'll have to be walked through the steps. If you sign up with your OCSB student email for brand new or learning in a school, and make sure you pick Python, and then you can pick 2 other ones. We're going to start working in Python today. Using this program, there are 2 parts. There's the input pane and the output side, which is the dark box. So here we can enter all kinds of different commands, like print. And we'll try something like hello world. And when you run it, by clicking the run button up at the top, you get your output in the output box. Here, all I did was ask the program to print, type out something in the output box, hello world, in quotation marks. There are all kinds of different types of data. A string is your text. So when you're typing things like text and even special characters, they are known as a string. Integers are a form of number. There are 2 kinds of numbers, integers being whole numbers and floating point numbers, which are float. And they contain a decimal. And then the 3rd kind of data type is a Boolean, which is either like positive or negative. It's either true or false. Notice the capital T and capital F. So why don't you try these things now? Print 1 plus 1. So keep in mind that we're having an open bracket here. And what do you think the output there would be? You run that. 2. Print true and false. Notice that the output is false, because AND is an operator and it's asking capital T, true and false. Something cannot be both true and false, so it says it is false. What about print true or false? This comes out as true because at least one of those 2 things is true. This one is true. What about print hello plus world? Hello world. Some of the operators, such as equals, does not equal, greater than, less than, or greater than or equal to, are for using with numbers. So these are with the integers. In this case, 2 is not equal to 2. We know that's not quite true, but let's check it out. It's telling us that is false, because 2 does equal 2. 4 is greater than or equal to 2. That is true, because 4 is bigger than 2. And hello world equals hello universe. Are they the same thing? Nope, that's false. All right, let's check out some variables. A variable is kind of like in math class when a letter X represented some kind of number, maybe it was an unknown number. Sometimes it is known what the variable is. X could equal 7. So sometimes you can call something, you give it a name, and that variable is the name, but then you assign some kind of a value. So here, Kawhi Leonard is the variable, and the value is, in quotation marks, fun guy. And that gets stored somewhere. So Kawhi Leonard is fun guy, and then we want to print our variable. And our output here is fun guy, because we're not printing Kawhi Leonard, we're printing the value of the variable. Well, the slogan, another variable, is Boardman gets paid. And if we set this variable equal to that variable, so Kawhi Leonard is one variable equal to slogan, then when we print Kawhi Leonard, what do you think will happen? Boardman gets paid. Let's take a look at some lists. So we have different kinds of lists. Some are for text or string lists. And you start out by setting your variable to equal a list with the square brackets and commas in between. An integer list has numbers. A Boolean list is either true or false. A floating list has numbers with decimals. And we can have a random list that has all different types of values. Now we're going to check on the length of lists. And notice that some of these titles start with a hashtag, and that's because a hashtag at the beginning of your code will turn it into a comment. So if you put a hashtag on those lines of code, it means that they won't be interacting with the program at all, and there's nothing that is telling the computer what to do. It's just it's for your own commentary to keep track of what's happening. We'll set a string list to A, B, and C. And then we want to print the length of the string list. The output here is 3, because the length of this list is that it has 3 things in it. Indexing, so the location of where something is in the list, starts at 0 for the first item and a 1 for the second item, and so on. Programmers like to start things at 0, so the very first item in a list, it'll have the index of 0. So you can ask where something is in a list, like where is the index number 2, and it'll return C, because C is in index number 2. So for this list here of A, B, C, D, printing what is in the index of 0. Add a D here. It tells us that A is in spot 0 or index 0. What's in the index 2? C, because it's in the third spot, 0, 1, 2. And what do you think is in -1? D, because 0 is A, and then go backwards 1 is -1, goes to the back of the list, and that is -1 spot. So -2 would be C, -3 B, and so on. So D. When you have your list, you can check if an element is in the list somewhere, and because A is an element that is in this list, that will be true. Of course, 2 is not in the list, so it would be false. You can also print you can print your entire list. You could just print the string list, or you could print a random choice. Now, random is a library that would have to be imported. So here we import random, and when you run that, you can see that it is printing a random element from the list. C, B, B, A. I want to print the entire list. There's the entire list printed. So a list is saving multiple pieces of information in one variable, right? So here the variable is str_list, and then the list is all the things that are saved, and they have different spots, and all these different things in there. The A, B, C, and D are elements. Looking at some conditional statements now. So your code that you're writing is going to be in this box, and then the output will come into that box there. So a conditional statement is an if-then, right? If something is true or not, then something else will happen. So here in real life, this happens to us all the time. If I am hungry, then I will eat an apple. If you're not hungry, then you won't eat an apple. So, hungry equals true, and remember this is a Boolean, either true or false. So if hungry is true, then you will print I will eat an apple. So let's try that. So here we have if hungry, so hungry is true, hungry equals true, and our condition, if hungry is true, colon, I will eat an apple. So you need the colon there, so that's the colon is the two dots above each other. Hungry is our variable, and you have to have a tab here. So if you just have it on the same line, then it's not going to run. Okay, Python likes things to be tabbed, not spaces. And the output is I will eat an apple. Okay, but only if that's true. Now if we change hungry to false, nothing gets outputted because it's only going to work if hungry is true, and now we just made hungry false.
So one thing you'll notice is that the second line here is indented, and in Python we use indents and not necessarily spaces. You could hit space a couple times, but indents are a little bit more just proper. We're going to take a look at some numbers here. So the code is setting a variable equals 4. So A is 4, B is 2, and our conditional statement, or our if-then statement, if A is less than B, then print option A. Else if, so this is another, like, you know, if that one's not true, but a different condition is met. If A is greater than B, then print option B. Otherwise, then else print option C. So if there's anything that's, you know, if it's not, the first one's not true, second one's not true, then the third one has an else option B. So let's take a look at that in some code here. So we've got, you know, A is 4, B is 2, and here's our conditional statement. When we run that, we get option B, okay, because A is not less than 4. So the first condition is not met, so it goes to the second one, and that one is met. A is greater than B, so 4 is greater than 2. What about if we change that to 1? So let's change A to 1 and run it, and our output is option A because A is less than B. 1 is less than 2. And the last time, what about if we make, you know, A is not less than, not greater than, and when we run that, we get option C because the first two conditions are not met. So as you can see, the different options there. Okay, we're going to take a look at some loops now. Basically, a loop is a set of instructions that repeats over and over until some kind of a condition is reached. Two types of loops are a for loop and a while loop. For loop is going to run a certain number of times that you tell it to, and a while loop is just running until the expression is true. So a for loop. Here we have for a number, num, that's a variable, in range. And so range is something that starts at 0 and goes until you set it to stop at something. We want to print the number. So what does that look like? So for the number in range all the way to 3, the third place, so 0, 1, 2, print the numbers. Okay, so there's a range here of 3, 0, 1, and 2. If we change that to 10, it would repeat, would loop, it's checking, starting at 0 and checking, add 1, or in the next integer, the next spot, the next spot, the next spot. It is looking for the range, right, from 0 onwards until it gets to the 10th spot. The other type of loop is a while loop. So here we'll set the number equal to 0, and while the number is less than 3, which of course 0 is less than 3, you're going to print the number, and then the number gets added. So a plus equals is taking the number and then adding 1 to it. Okay, so it's adding 1 more each time. When this loop, the number starts at 0 because we set the variable to 0, and as long as it's less than 3, it will print the number. So print the number, so prints 0, and then it adds 1 to that, and then it loops back and prints the number, that new number, 1, and then it adds another 1 to that, and then it prints the number 2, and then it will only stop once it hits this condition of the number not being less than 3. So it's only running this while the number is less than 3. So if we change that to 10, run it, you can see that it'll keep going as long as the number is less than 10. You could start the number wherever you like. You could start it at 4, and then 5, and then 6, and it's always adding 1 to it. And if you wanted to add 2 each time, 4, 6, 8. All right, now it's time for you to write some code. You have a challenge in front of you here, and that is to create some more difficult passwords that are not as easily hacked. We're now going to take a look at some of the tasks that you can do. There are 2 tasks. One is an easy one, and one is an advanced. It's your choice which you'd like to try, but they both will result in stronger passwords. So basically, the way to follow this document is one step at a time. Make sure you check things out line by line. If there's a link, you can click on that to get started. But otherwise, there's different kinds of commands here. So if it says do, then this is something you're actually going to do in the like to type it out and write it in the code there, and then to just try it. So click on the run button every once in a while, and if you get a bug, then you can head back to the document and try it out. When it says think, it's asking a question, and the answer is actually provided right there, but you should really try and think about your answer to the question. Like, think about what is being asked. When it says consider, kind of think of that like a teacher saying this out loud, but there's some important information for you to consider in order to get things done. And then the last type is do. Okay, so do is actually typing out the code. So for the easy task, basically what you're doing here is coming up with a list of a few favorite words, a few of your favorite special characters, and then choosing a random number, so import random, and then putting it all together. So, printing the word, the character, the number, and every time you run that code, you will get a different password. So here, 99 robots, tilde, and ampersand. So every time you hit run, it'll be something else. 58 ampersand Canada. Taking from these lists here and randomizing it, putting it all together at the end, even shuffling it around so that it is in a different order. It's not always just the word, the integer, and then the character, but being moved around. So that's the easy one, and here's what it should kind of look like at the end. So give that a try. Or you can choose the advanced challenge. Okay. And this is some code here that, you start off with an example password of hello world. And again, there's do, there's think, and there's consider. But you're putting together the code that would take a weaker password. So if someone were to type like just a straight up word, it's going to run some loops that will change some, depending on the position of where the letter is in the actual word. It will change E, could become like a lowercase e, could become a capital E, or even the number 3, because that kind of looks like an E backwards. This uses loops and conditional statements, so if-then statements, changing some of the characters in the older weak password to a new one. An A could become a 4, but it's basically just changing out some of the characters. So when you look at the actual code, okay, and you don't have to do all of these else-if statements, but it's searching through the word for a lowercase e, and it's going to change it to a 3 or a capital E, or it's going to leave it alone. It does that with O's or 1s and 3s. And changes them into a stronger password. So watch what happens when we run this. So enter a weak password. This is where you would actually type a weak password. So maybe hello world, and then hit enter. And now I have a new password, and it's, look at this, capital H3 exclamation mark L capital O. And so that is my new password there from the weak password. So that's an example of what this code, it'll create a program that would transform any old password into a weak one. And of course at the very bottom is this entire sheet is a step-by-step process that will allow you to line by line create this kind of code using Replit. But if you do get stuck, you can check out the w3schools.com and check out some of the tutorials in Python, or even search things up. Just try some things yourself.